For thousands of years, humans have looked up at the night sky and wondered a simple question: are we alone? When we look into space, we see billions of stars scattered across the darkness. Many of those stars are older than our sun. Many are surrounded by planets. In fact, modern astronomy suggests that planets may be incredibly common throughout the universe. Our own galaxy, the Milky Way galaxy, contains somewhere between 100 and 400 billion stars. And according to recent observations, most of those stars likely have planetary systems. That means there could be hundreds of billions of planets in our galaxy alone. Some of those planets orbit in what astronomers call the habitable zone, the region around a star where temperatures might allow liquid water to exist. And where there is liquid water, scientists believe there is a possibility for life. Now consider something even more astonishing. The observable universe contains not just one galaxy, but hundreds of billions of galaxies, each of them filled with stars, each of them filled with planets. When we multiply those numbers together, the result becomes almost impossible to imagine. There could be trillions upon trillions of habitable worlds scattered throughout the cosmos. Worlds where life might evolve. Worlds where civilizations might rise. Worlds where intelligent beings might build technology, explore space, and perhaps even look up at their own night skies and ask the same question we do: are we alone? Yet despite this enormous cosmic potential for life, we have never found clear evidence of alien civilizations. We have never detected a confirmed alien signal. We have never seen alien spacecraft. And we have never discovered undeniable signs of extraterrestrial technology. This contradiction between the vast number of possible civilizations and the complete lack of evidence is known as the Fermi Paradox. The paradox was famously discussed by physicist Enrico Fermi in 1950. During a casual lunch conversation with colleagues, Fermi asked a question that would become one of the most famous questions in science. He simply asked, "Where is everybody?" At first, the question seemed almost humorous. But the more scientists thought about it, the more mysterious it became. Because when we think about the age of the universe, the silence becomes even stranger. The universe is about 13.8 billion years old. Our planet, Earth, formed about 4.5 billion years ago. Life appeared on Earth surprisingly quickly, within only a few 100 million years. Over time, simple organisms evolved into more complex forms. Eventually, intelligent beings appeared. Humans developed language, science, and technology. And within only a few centuries, we began sending signals into space. Today, powerful radio telescopes scan the sky searching for similar signals from other civilizations. Projects connected to the SETI Institute listen for artificial radio transmissions that might come from distant stars. These telescopes search for patterns that nature normally does not produce. Yet so far, the results have been silent. No confirmed alien signals. No technological broadcasts. Just the quiet background of the cosmos. This silence is what makes the Fermi Paradox so fascinating. If intelligent life is common in the universe, then many civilizations should have had billions of years to develop advanced technology. Some might even have become capable of traveling between stars. The distance between stars is enormous, but on cosmic timescales, it is not impossible. Even a civilization traveling relatively slowly could colonize an entire galaxy within a few million years. And compared to the age of the galaxy, a few million years is only a moment. Which means that if even one civilization had begun expanding millions of years ago, their presence might already be visible everywhere. Yet when we look into the galaxy, we see no obvious signs of such expansion. No giant structures surrounding stars. No interstellar empires. No alien megastructures like the hypothetical Dyson sphere that could capture the energy of an entire star. Just stars, planets, dust, and silence. So where is everybody? Why does the universe appear so empty of intelligent life? Scientists have proposed many possible answers. Some explanations suggest that intelligent life is incredibly rare. Perhaps life itself is common, but the evolution of intelligence is extremely unlikely. Maybe simple microbial organisms exist on millions of planets, but complex civilizations almost never emerge. Another possibility is that civilizations do appear, but they rarely survive for very long. Advanced technology can be dangerous. A civilization might destroy itself through war, environmental collapse, or uncontrolled artificial intelligence. If most civilizations disappear shortly after developing technology, then the universe could be full of extinct worlds. Worlds where intelligence once existed but no longer does. This idea is sometimes called the Great Filter, a mysterious barrier in the development of life that most civilizations never pass. Some scientists wonder whether the Great Filter lies behind us or ahead of us. If it lies in the past, then humanity may be incredibly lucky. Perhaps very few planets ever develop intelligent life at all. But if the filter lies in the future, then it could mean that most technological civilizations eventually face some catastrophic challenge, and few survive it. Another possibility is even stranger. Perhaps alien civilizations do exist, but they are deliberately silent. Advanced civilizations might choose not to reveal themselves to younger species like us. Some researchers call this the cosmic zoo hypothesis. In this idea, humanity could be like animals inside a protected reserve, observed from a distance but not contacted, because interfering with our development might change the natural course of our civilization. Or perhaps alien technology is simply too advanced for us to detect. Imagine trying to explain the internet to someone living 1,000 years ago. To them, the signals would be invisible and incomprehensible. In the same way, alien civilizations might use communication technologies far beyond our understanding. Signals that our telescopes cannot detect, messages that we cannot decode. And if that is true, then the universe might not be silent at all. It might be filled with signals that we simply do not know how to hear. Some scientists believe the silence of the universe may have a much darker explanation, an idea known as the dark forest theory. This theory suggests that the universe might be filled with civilizations, but every civilization is hiding. Imagine walking through a dark forest at night. You know there might be other hunters hiding among the trees, but you cannot see them, and they cannot see you clearly either. If you make noise, reveal your position, or light a fire, you might attract attention, and that attention could be dangerous. In such a situation, the safest strategy is silence. Do not reveal yourself. Do not broadcast your location. Stay hidden. Some thinkers have suggested that advanced civilizations in the universe might follow a similar logic. In a universe where survival is uncertain, announcing your presence could be risky. You do not know who might hear your signal. You do not know whether they are friendly or hostile. And if even a single hostile civilization exists somewhere in the cosmos, it might be enough to make every other civilization cautious. So instead of shouting into space, they remain quiet, watching, listening, waiting. Humanity, however, has already begun doing the opposite. For more than a century, we have been broadcasting radio signals into space. Television signals, radar signals, satellite communications, all of these leak into the cosmos. Any advanced civilization within dozens of light years could potentially detect the faint glow of our technological activity. In other words, the Earth has already begun announcing its presence. Projects connected to the SETI Institute continue to search the skies for artificial signals. Powerful radio telescopes scan distant stars looking for repeating patterns or unusual transmissions. Meanwhile, other researchers have begun looking for a different type of evidence. Instead of listening for signals, they search for technological structures. If a civilization becomes advanced enough, it might begin constructing enormous engineering projects in space. Structures so large that they could change the light of entire stars. One of the most famous hypothetical examples is the Dyson sphere. This idea was proposed by physicist Freeman Dyson. Instead of building a solid shell around a star, an advanced civilization might construct a vast swarm of solar collectors orbiting around it. These collectors would capture a huge fraction of the star's energy output. From a distance, such a system would appear unusual. The star's visible light might dim slightly. At the same time, the collectors would release heat in the infrared spectrum. Astronomers have searched for stars with these strange signatures. So far, none have been confirmed. However, scientists have discovered a few mysterious stars whose brightness changes in unusual ways. One famous example is Tabby's star. This star exhibits irregular dips in brightness that puzzled astronomers for years. At one point, some researchers even wondered whether an alien megastructure might be responsible. Later studies suggested more natural explanations, such as clouds of dust orbiting the star. But the mystery captured the imagination of scientists and the public alike, because it raised an extraordinary possibility. What if somewhere in the galaxy, an advanced civilization really has built enormous structures around its star? If such civilizations exist, their technological footprints might be visible across vast distances. Astronomers are also searching for something called technosignatures. These are detectable signs of technology rather than biology. For example, a planet with a technologically advanced civilization might show unusual chemicals in its atmosphere. Artificial industrial gases could appear in spectral observations. Night-side illumination from large cities might even be detectable on nearby planets with future telescopes. In the coming decades, new observatories may dramatically improve our ability to search for such signs. One of the most powerful tools already studying the cosmos is the James Webb Space Telescope. This telescope can analyze the atmospheres of distant exoplanets and detect the chemical fingerprints of gases. Some of those gases might eventually hint at biological or technological activity. Meanwhile, missions led by NASA and other space agencies continue to explore the planets and moons of our own solar system. Places like Mars, Europa, and Enceladus may contain environments where microbial life could exist. Finding even simple life elsewhere in our solar system would change everything, because it would prove that life can emerge more than once. And if life appears easily, then the universe may be full of living worlds. Perhaps intelligent civilizations exist on some of them. Civilizations that developed long before humanity appeared on Earth. Civilizations that may be millions of years more advanced than we are. And if that is true, then our current technology might simply be too primitive to notice them. After all, when we look at the night sky, we are only beginning to explore the smallest fraction of the universe. Our own galaxy, the Milky Way galaxy, is about 100,000 light-years across. Even light, the fastest thing in the universe, needs 100,000 years to cross it. Human civilization has been using radio technology for just over a century, which means our detectable signals have traveled only about 100 light-years into space. A tiny bubble of radio noise expanding slowly into the galaxy. Beyond that bubble, the rest of the galaxy still has no idea we exist. And perhaps somewhere out there, another young civilization is also looking at the stars. Also wondering, also searching, also asking the same ancient question that humanity has asked for centuries. Are we alone? Or is the universe filled with countless civilizations hidden among the stars quietly observing the cosmos waiting to be discovered? And yet, despite all our questions, the universe continues to reveal new discoveries every year. In recent decades, astronomers have found something that changed our understanding of the cosmos forever. Planets are everywhere. Before the 1990s, scientists did not know whether planets around other stars were common or rare. Today, we know that they are incredibly abundant. Thousands of exoplanets have already been confirmed by missions, such as the Kepler Space Telescope and the powerful James Webb Space Telescope. These discoveries revealed that planetary systems are a natural part of star formation. Some planets are giant gas worlds larger than Jupiter. Others are rocky planets similar to Earth. And some orbit in the habitable zones of their stars, where liquid water might exist on their surfaces. Scientists estimate that in our own Milky Way galaxy alone, there could be tens of billions of Earth-like planets. Worlds with oceans. Worlds with atmospheres. Worlds where chemistry might slowly evolve toward life. If even a tiny fraction of those planets developed life, the galaxy could contain millions of living worlds. Yet the silence remains. This mystery has inspired scientists to create equations that attempt to estimate the number of intelligent civilizations in our galaxy. One of the most famous is the Drake equation, proposed by astronomer Frank Drake in 1961. The Drake equation does not give a single answer. Instead, it breaks the problem into several factors. How many stars form in the galaxy each year? How many of those stars have planets? How many planets could support life? How often does life actually appear? How often does intelligence evolve? And finally, how long do technological civilizations survive? Each of these questions contains enormous uncertainty, but together they help scientists think about the probability of extraterrestrial civilizations. If intelligent life evolves frequently and survives for long periods of time, then the galaxy could be full of advanced societies. But if intelligence is extremely rare, or civilizations destroy themselves quickly, then humanity might be one of the few technological species in existence. Another fascinating possibility is that intelligent life may not look anything like us. When we imagine aliens, we often picture creatures similar to humans or animals. But evolution on other planets could follow entirely different paths. Alien life might be microscopic, or it might exist in forms that are completely unfamiliar. Life could evolve in the oceans beneath the icy crust of distant moons. It might exist in methane lakes, as scientists suspect could happen on worlds similar to Titan, the largest moon of Saturn. Some researchers have even speculated about exotic life forms that might exist inside stars or within the clouds of gas giant planets. These possibilities may sound strange, but the universe often surprises us. On Earth alone, life has adapted to environments once thought impossible. Microorganisms have been discovered deep beneath the ocean floor, inside volcanic vents, and even high in the atmosphere. Some bacteria can survive intense radiation, freezing temperatures, and extreme pressure. These discoveries suggest that life can be far more resilient than we once believed. If life can survive in such extreme environments on Earth, it may also thrive in unexpected places throughout the universe. For example, several moons in our own solar system are considered promising candidates for extraterrestrial life. One of the most intriguing is Europa, a moon orbiting the giant planet Jupiter. Beneath Europa's icy surface lies a vast global ocean. This hidden ocean may contain more water than all the oceans on Earth combined. Another fascinating world is Enceladus, a small moon of Saturn. Enceladus ejects enormous plumes of water vapor and ice particles from cracks in its frozen crust. These plumes contain organic molecules, suggesting that complex chemistry is taking place beneath the surface. Future space missions may one day fly through these plumes and analyze them for signs of life. If microbial life were discovered on Europa, Enceladus, or any other world in our solar system, it would be one of the most important discoveries in human history, because it would mean that life emerged at least twice in the same solar system. And if life can arise twice here, it may rise everywhere. Which brings us back to the great mystery. If the universe may be filled with habitable worlds, if life could exist on countless planets, if intelligence could evolve across millions of civilizations, then why does the cosmos appear so quiet? Perhaps the answer lies in time. Humanity has been searching for extraterrestrial signals for only a few decades. On cosmic timescales, that is less than a single second. It may simply be too early. Civilizations may rise and fall across millions of years. Signals may appear and disappear long before we develop the technology to detect them. The universe might be full of civilizations that existed in the distant past or civilizations that will appear far in the future. And right now, we may simply be living during a quiet moment in cosmic history. But the search continues. New telescopes, new observatories, new missions exploring distant planets and moons. Each discovery brings us one step closer to understanding our place in the universe. Perhaps one day we will detect a signal. Perhaps one day we will discover life on another world. Or perhaps humanity will become the civilization that spreads intelligence across the stars. Until that day rise, the night sky will continue to inspire curiosity and wonder. Because somewhere beyond those distant stars, beyond the vast spiral arms of the Milky Way galaxy, the answer to one of humanity's greatest questions may still be waiting. Are we truly alone in the universe? Or are we simply the first to listen? As scientists continue searching the universe, another important idea begins to emerge. Perhaps the reason we have not yet found alien civilizations is not because they do not exist, but because space itself is unbelievably vast. Even within our own galaxy, the distances between stars are enormous. The nearest star system to Earth is Alpha Centauri. It lies about 4.37 light-years away. That may not sound very far, but even our fastest spacecraft would need tens of thousands of years to reach it. For example, one of the fastest human-made objects ever launched is the Voyager 1 spacecraft. Launched by NASA in 1977, Voyager 1 is currently traveling through interstellar space at about 17 kilometers per second. That speed sounds impressive, but at that pace, Voyager 1 would still need more than 70,000 years to reach the nearest star. This illustrates a profound challenge of the universe. Travel between stars is extremely difficult. Even a highly advanced civilization might find interstellar travel slow, expensive, or impractical. Because of this, civilizations may remain mostly confined to their own star systems. They might explore their local planets and moons but never expand across the galaxy. If that is true, then intelligent civilizations could exist around many stars, yet remain isolated from one another by the immense distances of space. The galaxy might resemble an archipelago of distant islands, each island containing its own civilization, each civilization developing independently. separated by light years of empty darkness. And unless those civilizations develop extremely powerful communication systems, they might never even know that others exist. Another possibility is that alien civilizations may communicate in ways we have not yet imagined. Human technology currently relies heavily on radio waves. Radio signals travel easily through space and can carry information across vast distances. But an advanced civilization might use entirely different forms of communication. They could transmit signals using lasers, neutrinos, or even exotic particles that we barely understand. Some scientists have even speculated about communication methods based on quantum physics. For example, the strange phenomenon known as quantum entanglement allows two particles to share a connection regardless of distance. Changes to one particle instantly affect the other. Although this phenomenon cannot currently transmit information faster than light, future discoveries in physics might reveal new possibilities. If alien civilizations use communication technologies far beyond our current understanding, their signals could be passing through our region of space without us ever noticing. In other words, the universe might not be silent. We might simply be listening to the wrong channels. This possibility has inspired scientists to broaden their search strategies. Instead of focusing only on radio signals, astronomers are now exploring many different kinds of potential technosignatures. For example, scientists are searching for unusual patterns of light that could indicate artificial activity. Some researchers examine distant stars for extremely precise laser flashes. Others analyze planetary atmospheres for chemicals that could only be produced by industrial processes. There are even studies exploring whether gravitational waves might someday carry artificial signals. Gravitational waves are ripples in spacetime itself. They were first directly detected in 2015 by the LIGO Observatory. These waves are normally produced by enormous cosmic events such as merging black holes or neutron stars. But in theory, an extremely advanced civilization might one day learn to manipulate gravitational waves for communication. Of course, that level of technology is far beyond anything humanity currently possesses. But it demonstrates an important point. Our understanding of the universe is still evolving. Many discoveries that once seemed impossible have eventually become reality. Just a few centuries ago, humans believed the stars were fixed points in the sky. We did not know that they were distant suns. We did not know that planets existed around them. We did not know that galaxies filled the cosmos. Every generation of scientists has expanded our view of the universe, and each discovery has revealed that reality is often far stranger than we expected. Because of this, many researchers believe the search for extraterrestrial intelligence may eventually succeed. Perhaps tomorrow, perhaps in 100 years, or perhaps in 1,000. But somewhere out there, round one of the countless stars scattered across the Milky Way galaxy, a civilization might be looking into the sky just as we are. They might have their own telescopes, their own scientists, their own questions about the cosmos. They might wonder whether life exists beyond their world. They might send signals into space hoping that someone, somewhere, will hear them. And perhaps one day, across the immense darkness between the stars, two civilizations will finally discover one another. A message will be detected. A signal will be confirmed. And humanity will realize that we are not alone. Until that moment arrives, the mystery remains. The universe is vast. The stars are countless. And the question that physicist Enrico Fermi asked more than half a century ago still echoes through science today. Where is everybody? Perhaps the answer lies just beyond the limits of our current technology. Or perhaps the answer will change everything we believe about life in the universe. But one thing is certain. The search has only just begun. And perhaps the most fascinating possibility of all is this. What if humanity is among the very first intelligent civilizations to appear in our galaxy? It may seem unlikely at first. After all, the universe is incredibly old. But when scientists examine the long history of cosmic evolution, they realize something interesting. The conditions necessary for complex life may not have existed until relatively recently. In the early universe, shortly after the Big Bang, the cosmos contained mostly hydrogen and helium. These are the simplest elements in nature. But life, at least as we understand it, requires more complex chemistry. Elements such as carbon, oxygen, nitrogen, phosphorus, and iron. These elements did not exist in large quantities at the beginning of the universe. They had to be created inside stars. Over millions and billions of years, stars fused lighter elements into heavier ones through nuclear reactions. When massive stars reached the end of their lives, they exploded as supernovae. These enormous explosions scattered heavy elements across space. Those elements later became part of new generations of stars and planets. Our own planet Earth is made from material forged inside ancient stars. In fact, every atom of carbon in your body was once created in the core of a star. Because of this long cosmic process, the universe may have needed billions of years before enough heavy elements existed to form rocky planets like Earth. Without those elements, complex chemistry and possibly life might not have been possible. This means that intelligent civilizations may only now be beginning to appear across the galaxy. Humanity might not be late to the cosmic stage. We might actually be early. Another intriguing idea is that intelligent life could be extremely fragile. Developing intelligence is only one step in a long evolutionary process. Surviving long enough to become a technological civilization may be even harder. On Earth, life existed for more than 3 billion years before humans appeared. For most of that time, the planet was inhabited only by simple organisms. Complex animals emerged relatively late in Earth's history, and technological civilization capable of radio communication and space exploration has existed for only a tiny fraction of that time. In fact, modern technology has been around for just a few centuries. On the scale of cosmic history, that is an incredibly brief moment. If many civilizations rise and fall quickly, the chances of two civilizations existing at the same time and within detectable distance would be very small. Civilizations might flicker into existence like brief sparks in the dark, appearing glowing brightly for a short time and then disappearing. If that is the case, then the silence of the universe may simply reflect the rarity of overlapping civilizations. The galaxy could have hosted many intelligent species across its long history, but most of them may have existed millions of years apart from one another, separated not only by space but by time. Yet despite these possibilities, the search for extraterrestrial life continues to expand. Scientists are developing increasingly powerful telescopes capable of studying distant worlds in extraordinary detail. Future observatories may be able to analyze the atmospheres of Earth-like planets and search for chemical signs of life. They may even be able to detect seasonal changes on distant planets, evidence of biological processes. Missions planned by organizations like NASA and European Space Agency aim to explore both distant star systems and the hidden oceans of moons within our own solar system. Meanwhile, humanity is slowly beginning to venture beyond Earth. Robotic spacecraft explore planets, asteroids, and comets. Space telescopes peer deep into the cosmos, and scientists continue searching the skies for faint whispers of distant intelligence. Perhaps one day, a telescope will detect a signal unlike anything seen before, a pattern that cannot be explained by natural physics, a message intentionally sent across the stars. Or perhaps the first discovery of alien life will not come from distant galaxies at all. It might come from within our own solar system, from beneath the icy crust of Europa or from the hidden oceans of Enceladus. Finding even the simplest form of life beyond Earth would change our understanding of the universe forever. It would mean that life is not unique to our planet. It would mean that biology is a natural part of the cosmos. And if life is common, then intelligence may eventually rise somewhere among the countless stars. Until that discovery is made, humanity continues to watch the sky, listening, searching, wondering. Because somewhere in the vast darkness beyond the spiral arms of the Milky Way galaxy, another civilization might be asking the same question, looking up at their own night sky, staring at distant stars, and wondering whether they are alone in the universe, or whether somewhere across the immense ocean of space another mind is looking back. And so the question continues to echo across science, philosophy, and human imagination. Where is everybody? Despite the silence we have observed so far, the search for extraterrestrial intelligence remains one of the most exciting scientific efforts in human history. Every year, our technology becomes more powerful. Our telescopes grow more sensitive. Our understanding of the universe becomes deeper. New observatories are being designed to study distant planets with incredible precision. Scientists hope that in the coming decades we may be able to analyze the atmospheres of Earth-sized worlds orbiting nearby stars. By studying the light that passes through these atmospheres, astronomers can identify the chemical fingerprints of gases. Some combinations of gases may reveal the presence of life, For example, the simultaneous presence of oxygen and methane in large amounts could indicate biological activity. On Earth, these gases exist together because life constantly replenishes them. Without life, they would quickly react and disappear. Future missions led by NASA and other space agencies aim to develop telescopes capable of detecting such signals from distant planets. These discoveries would not necessarily prove the existence of intelligent civilizations, but they would demonstrate something equally profound: that life itself may be common throughout the universe. Another fascinating possibility involves detecting signs of alien technology rather than alien biology. These signs are called technosignatures. Technosignatures could include unusual radio transmissions, artificial lights on distant planets, or large engineering structures built around stars. Astronomers are also studying whether powerful energy systems used by advanced civilizations might leave detectable traces in space. For example, a massive structure designed to capture the energy of a star, such as the hypothetical Dyson sphere, would alter the star's energy output. Instead of shining normally, the star might emit unusual patterns of infrared radiation. By searching for stars with strange infrared signatures, scientists hope to identify possible evidence of advanced technology. So far, none of these searches have produced definitive proof of extraterrestrial intelligence. But that does not mean such civilizations do not exist. It may simply mean that the universe is far larger and more complex than we currently understand. Consider the scale of the cosmos. The Milky Way galaxy alone contains hundreds of billions of stars, and the observable universe may contain hundreds of billions of galaxies. If intelligent life evolves even rarely, the total number of civilizations that have ever existed could still be enormous. They may simply be scattered across distances so vast that contact becomes extremely difficult. Yet humanity has already taken its first small steps into the cosmic ocean. Our spacecraft have visited every planet in our solar system. Our telescopes have observed galaxies billions of light years away. Our instruments have detected gravitational waves from colliding black holes. And we have even begun sending robotic explorers beyond the edge of our planetary neighborhood. The spacecraft Voyager 1 and Voyager 2 are now traveling through interstellar space. Each carries a small golden record containing sounds and images from Earth. These records were designed as a message for any civilization that might one day encounter them. They contain greetings in many languages, music from different cultures, images of our planet and our species. It is a small gesture, a quiet introduction from a young civilization that has only just begun exploring the universe. Perhaps millions of years from now, those spacecraft will drift near another star. Perhaps they will be discovered by an alien intelligence curious about their origin, or perhaps they will continue traveling forever through the darkness of space, silent witnesses to humanity's first attempt to reach the stars. Until the day we finally detect life beyond Earth, the mystery will remain. The universe is vast. The stars are countless. And somewhere among those distant lights may exist other minds, other worlds, and other civilizations. For now, we continue to look up, to explore, to question, because the search itself is part of what defines us as a species. Curiosity drives us forward. Wonder inspires discovery, and the possibility that we may one day hear a signal from another civilization continues to capture the imagination of humanity. Perhaps the universe is quiet, or perhaps it is waiting patiently for us to learn how to listen. Either way, the story of the cosmos is still unfolding, and humanity has only just begun to turn the first pages, and perhaps one day, that search will lead to the most important discovery in human history. Imagine a moment when astronomers detect a signal unlike anything ever observed before. Not a random burst of radio noise, not a natural cosmic phenomenon, but a pattern, a repeating sequence. Something clearly artificial, something clearly intelligent. Scientists would examine the signal carefully, testing every possible natural explanation. Could it be interference from Earth? A satellite? A pulsar? A previously unknown astrophysical process? Only after eliminating every natural possibility would researchers consider the extraordinary conclusion that the signal might have come from another civilization. Such a discovery would immediately become one of the most significant scientific events ever recorded. Observatories across the world would turn their telescopes toward the source. Radio antennas would begin monitoring the signal continuously. Teams of scientists would attempt to decode the message. If the signal contained information of mathematics, images, or language, or humanity might begin the slow process of understanding a completely alien intelligence. This moment would transform science forever. It would prove that intelligent life is not unique to Earth. It would show that the universe contains multiple civilizations. And it would raise countless new questions. Who are they? How old is their civilization? What technologies have they developed? Are they peaceful explorers or something else entirely? The discovery would also raise a difficult philosophical question. Should humanity respond? Some scientists believe that sending a reply would be a natural step. Communication could lead to an exchange of knowledge. Ideas from civilizations millions of years more advanced than our own might revolutionize science. Other researchers are more cautious. They argue that announcing our presence could carry risks. After all, we do not know who might receive our message, and we do not know their intentions. Because of these uncertainties, the question of active communication with extraterrestrial civilizations remains controversial. Some organizations have already attempted to send messages into space. One of the most famous examples is the Arecibo message transmitted in 1970 for using the massive radio telescope at the Arecibo Observatory. This message contained a simple encoded description of humanity, our solar system, and the structure of DNA. It was sent toward a distant cluster of stars. However, because that cluster is about 25,000 light-years away, the message will take tens of thousands of years to arrive. Even if someone receives it and sends a reply, the response would not reach Earth for another 25,000 years. This illustrates just how enormous the universe truly is. Communication across interstellar distances is extremely slow. Even at the speed of light, messages take years, centuries, or millennia to travel between stars. This means that conversations between civilizations might unfold across generations. A message sent today might not receive a reply until far in the future. In that sense, communication between stars would resemble a form of cosmic archaeology. Each message would be a snapshot of a civilization that may have changed dramatically by the time the reply arrives. Yet despite these challenges, the search continues. Scientists are building larger telescopes, more sensitive detectors, and more advanced observatories. Projects dedicated to finding alien signals continue scanning the sky. Meanwhile, astronomers are discovering more and more potentially habitable worlds. Some of these planets may have atmospheres similar to Earth. Some may contain oceans. Some may have climates capable of supporting life. Future telescopes may even be able to photograph Earth-like planets directly. Seeing another pale blue world orbiting a distant star would be an unforgettable moment in human history. It would remind us that our planet is not unique, that the conditions that created life on Earth may exist elsewhere, and that somewhere in the vast spiral arms of the Milky Way galaxy, other civilizations may have already begun exploring their own cosmic neighborhoods. Perhaps they have sent probes to nearby stars. Perhaps they have built immense structures in space. Or perhaps they are simply watching the universe quietly, wondering whether they are alone. For now, humanity continues its search, listening for signals, scanning distant planets, exploring the hidden oceans of moons. Each discovery adds another piece to the puzzle, and each year brings us closer to understanding whether life exists beyond Earth. Because if the universe truly contains countless stars and countless worlds, then somewhere out there beyond the dark expanse of interstellar space another civilization, we already know that we exist. And perhaps one day, we will finally hear them. And even if humanity never receives a signal from another civilization, the search itself may still lead to extraordinary discoveries. Because the effort to answer the question, "Are we alone?" pushes science to explore the universe in greater detail than ever before. It drives the development of new telescopes, new space missions, new technologies capable of studying distant worlds. In the process, we learn more about our own planet, our own solar system, and our own place in the cosmos. Consider how much our understanding of the universe has already changed in just a single century. 100 years ago, astronomers did not yet know that the universe contained billions of galaxies. This discovery came from observations made by astronomer Edwin Hubble, who demonstrated that faint spiral nebulae were actually entire galaxies far beyond our own. His work revealed that the universe is vastly larger than scientists once imagined. Since then, our cosmic perspective has expanded even further. Modern telescopes have observed galaxies billions of light-years away. They have revealed stars being born inside glowing clouds of gas. They have captured images of distant planetary systems forming around young stars. They have even photographed the shadow of a black hole. In 2019, scientists working with the Event Horizon Telescope produced the first image of a black hole in the galaxy Messier 87. This remarkable achievement required observatories around the world to work together as if they were a single telescope the size of Earth. It demonstrated how powerful international collaboration can be when scientists pursue a shared goal. The search for extraterrestrial life may eventually require similar global cooperation. If a signal from another civilization were detected, scientists everywhere would work together to verify and analyze the discovery. Astronomers, physicists, mathematicians, linguists, and computer scientists might all contribute to decoding the message. Understanding an alien language could become one of the most complex intellectual challenges humanity has ever faced. Because an alien civilization may think very differently from us. Their mathematics might be familiar, but their culture, biology, and perception of reality could be completely different. Communicating across such differences would require patience, creativity, and careful study. Yet even if direct communication never occurs, the discovery of life elsewhere would still transform our understanding of the universe. Imagine discovering microbial organisms living beneath the ice of a distant moon, or finding chemical signatures of life in the atmosphere of a faraway planet. Such discoveries would reveal that life is not unique to Earth. Instead, life would be recognized as a natural outcome of cosmic evolution. Just as stars form from clouds of gas and planets form around stars, life might emerge wherever the right conditions exist. If that is true, the universe may be filled with living worlds. Some of them may host simple organisms. Some may host complex ecosystems. And somewhere, perhaps on a distant planet orbiting a quiet star, intelligent beings may have evolved their own civilizations. They might build cities, develop science, create art and culture, and like us, they might look up at the stars with curiosity and wonder. They might build telescopes to study the universe. They might send probes to nearby planets. They might even search for signs of life beyond their world. Perhaps they have already asked the same question that humanity continues to ask: are we alone, or is the universe filled with countless minds exploring the cosmos? For now, the answer remains unknown. But the journey to find that answer has already changed humanity forever. Because the search for extraterrestrial life reminds us of something profound. Our planet is a small world orbiting an ordinary star. Our civilization is young, and our knowledge of the universe is still incomplete. Yet despite these limitations, we have begun exploring the cosmos. We have sent spacecraft beyond the planets. We have built telescopes capable of seeing galaxies billions of light years away. And we have begun searching for signals from other civilizations. These achievements reflect something remarkable about our species: curiosity, the desire to understand the unknown, the willingness to look beyond our world and ask questions about the universe itself. Perhaps that curiosity will one day lead us to discover that we are not alone, or perhaps it will reveal that humanity is one of the first intelligent civilizations to emerge in the galaxy. Either way, the search continues. And every night, as we look up at the stars shining across the vast spiral arms of the Milky Way galaxy, we are reminded that the universe still holds many mysteries. Among those mysteries may lie other worlds, other forms of life, and perhaps even other civilizations waiting to be discovered. Until that day comes, humanity will continue listening, because somewhere in the darkness between the stars an answer may already be on its way. And perhaps the most important part of this story is not just the possibility of finding other civilizations. It is the perspective that the search itself gives us. When we step back and look at our planet from a cosmic point of view, something remarkable becomes clear. Earth is incredibly rare. It is a small world floating in the darkness of space, warmed by the light of a single star. From a distance, our planet would appear as a tiny blue dot orbiting the sun. Yet on that small world exists an astonishing diversity of life: forests, oceans, mountains, and deserts. Millions of species interacting in complex ecosystems. And among them, a single species capable of asking questions about the universe itself: human beings. When astronauts first saw Earth from space, many of them described a powerful feeling known as the overview effect. Looking at our planet from orbit, they realize how fragile and unique it truly is. There are no borders visible from space, no political divisions. Just one small world surrounded by the infinite darkness of the cosmos. This perspective changes how we think about our place in the universe. Whether we eventually discover other civilizations or not, humanity already represents something extraordinary. We are a species capable of exploring the cosmos. A species capable of understanding the physics of stars and galaxies. A species capable of sending machines beyond the edge of our solar system. And perhaps one day, we may become a species capable of traveling between the stars. The distances involved are enormous, but scientists have already begun imagining possible technologies that could make interstellar travel possible. Some concepts involve powerful laser systems pushing extremely light spacecraft to incredible speeds. One such project is the Breakthrough Starshot Initiative. The ideal is to accelerate tiny spacecraft to a significant fraction of the speed of light using powerful ground-based lasers. If successful, these spacecraft could reach nearby stars within a few decades. Such missions could provide the first close-up images of planets orbiting other stars. They could search for signs of life on distant worlds. And they might even carry small messages from humanity, a greeting sent into the galaxy. These early attempts would be only the beginning. Over centuries or millennia, future generations of humans may develop technologies far more advanced than anything we can imagine today. They might build large interstellar ships, they might establish settlements on distant planets, or they might create robotic explorers capable of traveling across the galaxy. If humanity survives and continues advancing for millions of years, our descendants could eventually spread across many star systems. From the perspective of cosmic history, this possibility is not unrealistic. The Milky Way galaxy is billions of years old. Even relatively slow expansion across the galaxy could eventually reach thousands of star systems. And perhaps, somewhere far in the future, humanity itself could become the answer to the Fermi Paradox. A civilization that begins exploring the galaxy and encounters other forms of life along the way. Some of those civilizations might be more advanced, others might be younger, and together, they might form a vast network of intelligent species spread across the stars. But all of that lies far in the future. For now, humanity stands at the very beginning of its journey into the cosmos. We are a young civilization on a small planet. Our technology is still developing. Our understanding of the universe is still growing. Yet even at this early stage, we have begun asking one of the most profound questions imaginable. Are we alone? The answer may come from a distant star, from a signal traveling across the galaxy, from a microbial organism living beneath the ice of a frozen moon, or from a planet orbiting a faint red star far beyond our solar system. Wherever the answer lies, discovering it would transform humanity forever, because learning that we share the universe with other forms of life would change how we see ourselves. It would show that intelligence is not unique to Earth, that life can arise in many different places, and that the cosmos may be filled with countless stories unfolding among the stars. Until that discovery is made, the search continues. Night after night, telescopes scan the sky, spacecraft explore distant worlds. Scientists analyze signals arriving from the depths of space. Each observation brings us a little closer to understanding the true nature of the universe. And somewhere among the billions of stars shining across the spiral arms, the Milky Way galaxy, the answer may already exist, waiting patiently for us to discover it. And perhaps in the distant future, humanity will look back on this era as the very beginning of a much larger journey. Right now, we are still a young technological civilization. Our first radios began broadcasting signals into space only about a century ago. Our first spacecraft left Earth's atmosphere only in the middle of the 20th century. And our first robotic explorers began traveling beyond the planets just a few decades later. Yet in that short time, we have already accomplished something remarkable. We have sent machines to every planet in our solar system. We have explored the surfaces of Mars and Venus. We have flown spacecraft past distant worlds like Pluto. And we have begun sending probes beyond the boundary of our solar system itself. The spacecraft Voyager 1 and Voyager 2 are now traveling through interstellar space. They carry with them small golden records containing sounds, music, and images from Earth. These records were created as a kind of message or greeting from humanity to whatever intelligent beings might one day encounter them. Of course, the chances of those spacecraft actually being discovered are extremely small. Space is unimaginably vast. Even after traveling for millions of years, the Voyager probes will pass relatively close to only a few stars. Yet the gesture itself is meaningful. It reflects humanity's desire to connect with the wider universe. It shows that even at the earliest stage of our exploration, we are already thinking about communication beyond our world. And perhaps one day, our descendants will build far more advanced explorers, machines capable of traveling between stars, robots designed to investigate distant planetary systems, probes that could search for oceans, atmospheres, and perhaps even life on distant planets. Such missions might reveal something extraordinary: a planet covered in oceans and clouds, a world where life has evolved along a completely different path, or perhaps even a planet where an intelligent species has built its own civilization beneath an alien sky. Discovering such a world would transform our understanding of life in the universe. It would show that intelligence can arise more than once, that evolution can produce thinking beings on more than one planet, and that humanity is part of a much larger cosmic story. But even if we never find another civilization, the exploration of the universe will continue to shape our future. Because the technologies we develop for space exploration often lead to new discoveries here on Earth. Satellites improve communication and navigation. Space telescopes expand our understanding of physics. Planetary missions teach us about climate, geology, and the origins of life. In other words, the search for life beyond Earth also helps us better understand life on our own planet. And perhaps that is one of the most important lessons of the Fermi Paradox. It reminds us that our world is precious. In the vast darkness of space, Earth is currently the only place we know where life exists. It is the only world where forests grow, oceans flow, and living creatures evolve. Protecting that world may be one of the most important responsibilities humanity has. Because if intelligent life is rare in the universe, then every civilization may represent something incredibly valuable. A rare spark of awareness in an otherwise silent cosmos. And if humanity truly is one of the first intelligent civilizations to appear in our region of the galaxy, then our future could be even more important. We may eventually become explorers of the stars, carriers of life beyond our home planet, a civilization that spreads knowledge, curiosity, and discovery across many worlds. Perhaps millions of years from now, descendants of humanity will live on distant planets orbiting other stars. They may build cities beneath alien skies. They may look up at the night sky of those worlds and see our home galaxy, the Milky Way galaxy, stretching across the darkness. And they may remember that their long journey began on a small blue planet orbiting an ordinary star, a planet where curious beings first looked up at the night sky and wondered whether they were alone. For now, that question remains unanswered. But the search continues. Telescopes listen, spacecraft explore, scientists study distant worlds and faint signals from across the cosmos. And somewhere among the countless stars shining in the vast spiral arms of the Milky Way galaxy, the answer may still be waiting for humanity to discover it.